just the fraction format. So things like this. So how do we graph these type of situations as well? Okay. And to be honest, they're not that difficult. It just again is a little steps. There's a lot of steps to deal with it when it comes to it. Okay. So before we actually learn how to graph those type of things, there's two very special things we're gonna have to learn, and they're called vertical and horizontal asymptotes. Okay. So just a quick rundown of what a vertical asymptote represents is a vertical asymptote is a vertical line going up or down, usually denoted as a dotted line, where the graph never passes. Okay, so meaning like if it's going this way, it bumps up, and going the other way, it just bumps down and never passes that individual line. So it's going to either go straight up or straight down, close, very, very close to that vertical line. And same thing applies for horizontal, right? So horizontal is just the opposite, just going this way instead, right? But it's the same process as what a vertical represents, okay? So these are the two major things we need to find before we actually graph any type of rational. And find vertical asymptotes are very, very simple. It's easiest of the two. Is the first thing you want to do is we're going to simplify the rational, meaning we're going to factor top and bottom and cancel anything that we could cancel out to begin with, right? So just like simplifying the fraction. So for example, if we have like, this, the first one you want to do is simplify. So divide by 2. So that's what I mean by simplify the fraction, right? Simplify the rational, just break it down to its bare basics. Okay. Next thing is we're going to set the denominator equal to 0 and just solve for the variable. In other words, set the bottom equal to 0 and solve for x. Whatever those x values are your vertical asymptotes automatically. Okay. So again, not too bad, right? When it comes to it, again, the most work you'll be dealing with is probably number 1 because you're just simplifying. Everything else is going to be pretty straightforward when it comes to it. Okay. So let's just try some examples so we can see how this is going to go there. Okay. So let's find the vertical asymptotes of each case here. Okay. So step 1, we want to make sure it's simplified. And it looks like we can't factor anything out from anything, right? So it's done. Step 1 is done. Right. So step 2 now is we're going to set the bottom equal to 0, only the bottom. We literally don't even care about the top. So literally just the bottom equal to 0 and solve. There you go. So therefore, we have a vertical asymptote at x equals 1. So again, if I'm just going to plot this at x equals 1, we're going to have a dashed line there. That's what that represents once we start graphing this. That's it. That's all we're going to do to find vertical asymptotes. Any questions? Yeah. Okay, so let's keep going to B. Same thing, step 1, we want to simplify. And there's nothing I can factor out on the top or the bottom, right? There's really nothing I can do. So again, this is also done, so it's even better. Less work we have to do. And now, so again, set the bottom equal to 0 and solve. So we have a vertical asymptote at x equals 2/5. Okay. So same thing, right? If we're going to eventually graph this at roughly 2/5, we're going to have a vertical asymptote there. Okay. All right, so when if you actually have to do like number 1, simplifying it. So now look at C. So C, first thing we want to do is simplify top and bottom. So it means we're going to factor, and this one we can actually factor stuff out, right? So it's been a while, so let's see if you guys remember. This is actually called the difference of squares formula. It looks like this. If you have x squared minus y squared, this is factored to x minus y times x plus y. So in this case, that's going to be x, and then the square root of 9 is going to be 3, right? So the top actually factors to x plus 3 and x minus 3 when it comes to it. Okay. All right, divided by, again, just factor the bottom. So we just do the AC method. That's going to be 9 and 6. So it looks like 3 and 3 work. So the factor of the bottom is going to be x plus 3 and x plus 3. So 2 copies of it. Okay. So we going any further? All good with the simplified? Good. In that case. Now we go on to step 2. So simplifying this, so notice a whole set cancels, right? One on top, one on the bottom, so that goes away. So literally, we just have this happening. Very similar to the way we had on part A. So that's all we're looking for now. Which means for step 2, we set the bottom equal to 0 and solve. So that's why we first have to simplify, because we actually only have one vertical asymptote instead of 2. If you just, set that equals 0, you would get 2. We actually only have one itself. So step 1 is actually very crucial. So any questions on finding vertical asymptotes of rational functions?
Not really a question on that, but how we factored the x squared minus 9, the whole x squared minus y squared. That's something we'd use also like on last night's homework, right? I was just getting tripped up on that. I was gonna wait till after, but that's just how you factor that out.
Yep, it's just the way it's just the rule. This is the equation to do it.
Okay, cool. Thank you.
You need to figure out what squared gives you that, and then what squared gives you the 9. So then, what squared gives you 9. So if you want, you could just write this, like what goes in the parentheses to give you 9. That's going to be 3. So that's going to be the y term when it comes to it, yeah. And that could change it, right? It could be 16. And you do the same thing. So what squared will give you 16? And there's always just one number itself. So then 4 would be the y in this case, yeah. Yeah, so 25, that's going to be 5, all the other ones when it comes to it.
And if it was a number such as 2?
If it was 2, you can do it. Because there's no number
right.
When you square it would give you 2 out, right? Unless the square root of 2. But we're not going to be dealing with that too much when it comes to it. You would just leave it like that.
Okay.
But I guess you could technically do it, but we're not going to go that far. Yeah.
Right. Thank you.
Any other questions? Okay. So verticals are the easiest of the two. The reason why is because it's pretty straightforward. Simplify, set the bottom equals 0, and solve. Now, horizontals are a little different because we actually have situations happening because of this when it comes to it. So horizontal and something called oblique asymptotes, which you will rarely see. I'll give you guys when this happens, but in most cases you never see an oblique asymptote, but mostly horizontal. All right, so let's consider our rational function. So again, this looks like it's a horrible mess, but just think of these examples. These are the examples I'm talking about when I say this. Okay. All right. Now, to find the horizontal asymptote, it's going to be into one of these 4 categories. So it says if the degree of p of x, so if the degree of the top is n and the degree of the bottom is m, so like for example here, the degree of top is 2, the degree of the bottom is 2. That's what it means by those n's and m's there, okay? Now, if the top degree is less than the bottom degree, then the line y equals 0 is automatically your horizontal asymptote. So an example of that would look like this. So the top degree is 1, bottom degree is 4, right? So top is less than the bottom, therefore y equals 0 is automatically your horizontal asymptote. If the top degree is equal to 1 plus the bottom degree, oh sorry, I missed that one. If the top degree is exactly the same as the bottom degree, so 1 and 1, 2 and 2, so notice all of these are the same, 1 and 1, degree 1 and 1, 2 and 2. So if you have anything of these situation happening, then the line a sub n over b sub n. So what this means is it's going to equal to the numbers in front of the variables. So for example, if I look at b here, top degree is the same as the bottom degree. So if I look at this one, the number in the front is a 2, divided by the number in front of that one is a 5. So the line y equals 2 or 5 would be your horizontal asymptote there. So these are the coefficients in front of the variables. So this will be 1 over 1. This will all be 1 over 1, right? Because those are the numbers in front of the variables for number 2. All right, number 3. This is the worst of them all. So if the top degree is equal to 1 plus the bottom degree plus 1, then we have to use long division because we have something called an oblique asymptote. Now, an oblique asymptote is not an up or down, it's actually a line itself. So it's a dashed line. So it reflects all over this stuff when it comes to it. Again, you will rarely see these because these are the most weirdest ones of all when it comes to it. We'll do an example so you can see how this works out, but you probably won't see it in this class and probably not even in calculus if you guys go a bit higher when it comes to it. Okay. So how would this look like? Like that. Top degree is equal to 1 plus the bottom degree, right? 1 plus 1 gives you 2. That's when you see in situation 3. Okay. And the easiest of them is the last one. If the top degree is way bigger than the bottom degree, we have no horizontal and no oblique. So, for example, like this. Right? Top degree is far bigger than the bottom. We have none, no horizontal whatsoever. So when it comes to horizontal, you just want to identify which situation you're in, and that will tell you exactly what's going to be your horizontal asymptote. Okay. All right, so let's just try putting these to practice and see what we get. Okay. All right, here's the first one here. So remember, for horizontal, we don't have to simplify. We're just looking at degrees. Okay. So this is a 3, and this is a 6. Okay. So bottom degree is far bigger than the top. So which situation are we in for part A? 1, 2, 3, or 4?
1.
Yep, 1. Right? So top is smaller than bottom. So therefore, y equals 0 is automatically your horizontal asymptote. So pretty much no math except for number 3 when it comes to it. Just identifying which situation you're in and just plug it in there. Right. Let's look at B. So degree on top equals degree to bottom. So therefore we're at second situation. So the line y equals, it's going to be a fraction. And the number that's attached to x squared is a 3. The number attached to x squared on the bottom is a 17. So the line y equals 3 over 17 is your horizontal asymptote. So questions so far on A or B? No, not too bad. Okay. So if we go on the next page, let's try C now. So C, this is 3, and this is 2. Okay. So that actually is situation 3, because the top degree is 1 plus the bottom degree, right? 1 plus 2 gives you 3. So in other words, we have to do long division. So I will show you how long division works. Again, you probably won't ever see this again, but just in case you want to see what's actually happening. Let's see if I can fit it on here. Okay. So how this works is, right, what times this will give you this? That's essentially, when it comes to just basic division with numbers, right? So 3x, right? That's what we're missing. 3 times this will give you the 3. X times x squared gives you x to the 3rd. And now what you want to do is distribute this to both of them. So if I do this one, make it exactly that. And 3x times 2 gives you 6x. And then you subtract. Now, these cancel, right, which is the most important thing, but these don't touch, right, because they're unlike terms. So what happens is you actually do those instead. So you're going to be minus 2x squared, and it's going to be minus x plus 6x gives you 5x, and then you just repeat the process you just did. So then what times this will give you that? So you minus 2, and then 2 times 2, or negative 2 times negative 2 gives you positive 4, and then you repeat the process. So then subtract down, so those cancel, and again, these are unlike terms, so it's going to be 5x, and then you're going to add the 4 and the 10 together. Okay. Now again, notice there's no number when you multiply you can get you that, so you're stopping there. So this is your remainder. So your oblique asymptote is the line y equals 3x minus 2. And that's why the third step is the most difficult and the weirdest one. Okay. Again, you probably won't even see this, but I just want to give you guys an example of it so you can see, you know, how that you would get an oblique asymptote. Okay. So in fact, you don't even care about this. You just care about the top once you do all that. So a little less on long division, if you guys remember, or if you guys don't remember, you know, that's what the horribleness of long division there. Right. And the last scenario is D. So the degree here is 10. This is 2. So when the top degree is way bigger than the bottom, we're in number 4. Therefore, we have no. So do we have none? Right, that's the best one. No horizontal or oblique whatsoever. So before we go any further, any questions on finding horizontal or vertical asymptotes? No, all good? Okay, so if that's the case, believe it or not, we actually have all the stuff we need to start graphing these stuff. Okay, now to graph these individually, it's not too difficult when it comes to it. We're actually going to be skipping step 1 because you'll see why in a little bit. So all we really care about doing is just finding our vertical and horizontal asymptotes. We're just going to start there, okay? And then after we find those, we're going to pick numbers to the left and to the right of these asymptotes and then graph it individually using a T-chart, okay? But again, you know, we'll slowly take our time, okay? So we're just going to do what we know how to do it. Just find our vertical and horizontal first, okay? So again, we'll just do the easy one first. Let's do the vertical. So if we do vertical, therefore we're going to have to factor, right? So factor top and bottom. Now notice the bottom is a situation I already showed you guys earlier, right? It's a difference of squares. So x squared gives you x squared, 2 squared gives you 4. So therefore this ends up being x plus 2, x minus 2. And just to give you guys a heads up, that's actually one of my favorite factors. So you may want to remember how to do this pretty easily, right? Again, I can just tweak this to be 25, 49, 81, right? It's just the same process there. Okay. Now for the top, we're going to have to do the x method. So let's see what we get there. Two times 2 is 4. This is -5. So it looks like -4 and -1 work. Okay. All right, so our factors are 2x minus 4 and 2x minus 1. Okay. Now, remember, we want to factor completely. So if you noticed right here, they have a number in common. And the number is 2, right? 2 and 2. So we could take out a 2 from here to factor it completely. So divided by 2 just gives an x, and then divided by 2 gives you the 2 there. Okay. So that's factored completely. There we go. All right, so now that we factored completely, now we can simplify, and look at that. Stuff cancels out, which is a nice part. So we're just left with 2 on top with a 2 minus 1 all over just a x plus 2. Okay. And now to find vertical, we set the bottom equal to 0 and just solve. So our vertical asymptote is the line x equals -2. So far, so good for everybody? Okay. All right, next up, find our horizontal asymptote. So again, right, this one is situation-wise. So let's look at the power. All right, so power on top is 2. Power on bottom is 2 as well. So therefore, if you guys look at your notes, we're actually in situation 2, same degree. So it's align the numbers in front of them when you divide. So here, it's going to be y equals 2 divided by 1, or just y equals 2. So far, so good for everybody? Okay. All right, now we're just going to graph these two lines. Remember, these are vertical lines and horizontal, so straight and up and down, right? So vertical at -2, so vertical means up. We're just going to make a dash. And then at +2, so in other words, this way. Okay. All right. Believe it or not, we're actually almost done. Now, the last step we're going to do is make a little t-chart. Okay. Now, this is what I meant by this one here. Choose numbers between the zeros to see the curvature of the graph. What I'm saying there is, notice this vertical line cuts the graph in half. This is one side, this is another side, right? It just cuts it in half. So what we're going to do is we're going to pick numbers to the left of this line and numbers to the right of that line. That way we can see what the graph is actually going to look like. Okay, and you can pick any numbers you like. I'll just do the closest ones to it. So I'll put -3, -4, and let's say -5. Okay, and then we're also going to pick numbers to the right of it. So to the right, it's -1, 0, and let's say 1, right? Just a couple. And then all we're going to do is plug and chug, right? Right. It's just like a regular t-chart we did in chapter 1. And the best part is you can plug it right here to make it easier instead of plugging all into all that stuff here. Okay. So we're just going to plug it in. So we're going to plug in -3, so forth, and see what we get out when it comes to it. Okay. So let's see. So -3 times 2 is -6. -1 is -7 times 2. So it's -14 on top. It's -14. And on the bottom, you get -1. So you get +14. I think that's what I get. If we keep going, plug in -4. So -4 times 2 is -8. -1 is -9. Times 2 is -18. Divided by -2 plus 2 is -2. So divided by -2 gives you +9. Keep going. So that's going to be -10, -11 times 2. So the top is going to be -22. On the bottom, you're going to have -3. So divide by -3. So I'll get the decimal, positive 7.33. All right, just a couple more. Negative 1, that's negative 2, so that's negative 3 times 2. That's negative 6 on top, divided by negative 1 plus 2 is positive 1. So divide by positive 1, so it keeps the negative. Okay, all right, 0 is an easy one. That goes away. So 2 times negative 1 is just negative 2, divided by positive 2, negative 1. And then final last one. So 2 minus 1 is 1. 1 times 2 is 2, divided by 1 plus 2 is 3. So 0.667-ish. Okay, so I know that I did pretty quickly. Everybody good where I got these numbers? If you want to, I just use a calculator, make it a little faster. Everybody good? I know, we just plot them all. So as best we can. So negative 3, 14 is way up here. Negative 4, 9, just right here. Negative 5 and 7, so right here. So it looks like on this side it's going like that. And remember, it's never going to cross this, so it's going to shoot straight up. And now on the other side, negative 1, negative 6, 0, negative 1, and then 1 and 0.6 up here. So it looks like it's doing this on this side. And there you go. That's exactly how we're going to graph them. So first thing is find vertical and horizontal, graph those. And the next thing is just make a T-chart, getting numbers to the left and to the right of your vertical asymptote. And voila. All right, let's try the next one so you get a little more comfortable. All right, x minus 2 over x squared. So good thing here, it's already simplified, right? So check. So that means to find our vertical asymptote, we set the bottom equal to 0. No, take the square root. Square root of 0 is still 0, right? Doesn't help. So our vertical asymptote is a line x equals 0. All right, so now we go into horizontal asymptote. So this situation, the bottom is bigger than the top. So we have the bottom is bigger than the top. So the line y equals 0 is our horizontal, right? Like this situation here. So we have y equals 0. These are horizontal asymptotes. Now, if you're wondering, how do we graph these? Well, these are actually the axes themselves. So it's like this line here. That's your horizontal. And your vertical is this one here. So it's literally the x and y axis is our horizontal and vertical asymptotes. Meaning it's not going to cross all that fun stuff. Or maybe. Okay. All right. So far, so good. Okay. So now we just make a T-chart. Again, this is our vertical. Pick numbers to the left, to the right. So let's see. So let's just go down the list. Negative 1, negative 2, negative 3. That's to the left. Now to the right, let's do the positives. And now we just plug and chug, right, and see what we get out. Okay. Plugging in negative 1. All right, let's see what we get. So negative 1 minus 2 is negative 3. So it'll be a negative 3 on the top. And on the bottom, it's going to be positive no matter what, because it's squared, right? So that's going to be negative 3. So in other words, whatever we get to the top is just going to be 1 there. So plug in negative 2 now. Negative 2 minus 2 is negative 4. we have negative 4 on top. This is going to be positive 4. So negative 4 divided by positive 4 gives you, negative 1. Negative 1. Okay. Minus 3. So negative 3 minus 2 is negative 5. On the bottom gives you 9. So we get negative 5/9, or in decimal form, that gives you about 0.56. So negative 0.56. Okay. And now we just do the positives. So 1 minus 2 is negative 1. 2. 2 minus 2 is 0. So 0 divided by anything is just going to be 0. So I know that for sure. And then 3. So 3 minus 2 is 1. That's a 1 on top. And 3 squared is 9. So this is 1 over 9, or approximately 0.11. Okay. And now again, we just graph all these points. I guess I best we can, right? So negative 1, negative 3, so it's down here. Negative 2, negative 1. Negative 3, and negative 0.56, so like super close to it, right? So we know on this side, it's going down because it's never going to cross this. It curves and just kind of like flattens out there. And on the other side, we get 1, negative 1, 2, 0. Oh, that's interesting. And then 3 and 0.11, so like right there. Oh, so on this side, it goes down this way. It crosses the horizontal and it just flattens out like that. Well, that's interesting. I told you, it's not supposed to cross it. Well, here's a fun little fact of it. Hopefully you guys write this down. When it comes to horizontal asymptotes, the graph can cross it. Okay, I'll say it again. When it comes to horizontal asymptotes, the graph can cross it. And you'll find out an exact particular point if it crosses it. But it will never cross vertical asymptotes. Okay. You got that down? Anybody want me to repeat it? Good. Is everybody good? So any questions on B at all? Okay. A couple more, get you guys more practice. All right. For this one, we are going to have to simplify. So simplifying the top, we can factor out a 3x, because that's what they both have in common. So we just said with x minus 1 on the top. And on the bottom, you're going to have to do the x method to factor. So minus 12 and a 1. So two numbers when you multiply give you negative 12, but add up to give you 1. 6 and 2 won't work. So the only other pair that we have would be 4 and 3. It looks like maybe 3 has to be negative. So this is x plus 4 and x minus 3. So, oh, dang it, nothing cancels. So we didn't have to factor anything. All right, so now we set the bottom equal to 0, because when we're vertical asymptotes, so set the bottom equal to 0 and solve for x. So that means we just set both to 0 and solve for x. So this time we're going to have two vertical asymptotes. It's x equals negative 4 and x equals positive 3. All right. And here's your first extra credit for today. What is our horizontal asymptote? Give you guys a quick minute to get that. So y equals what? Go for it. All right, you guys got it? Y equals 3. Good. All right, so now let's just graph those lines. So -4, so we have going up, down, and 3, down, and at 3 here. So this one already looks a little different than the last one, right? When it comes to it. So because we have 2 verticals. So which means when we do our T-chart, it's going to be a little different as well. So now our graph is broken into 3 parts: the left, the middle, and also the right-hand side. So what we're going to do is it's going to do a little bit more work because we have one extra space to fill. So if I just look at this vertical here, and again, let's pick up some numbers to the left and to the right. So to the left of it would be -4, -5, or no, is it -5? Yeah, -5, sorry. -5, -6, -7. Okay. Now on this side, we can try, well, let's just do the little one. Let's say -1, 0, and 1. These are kind of nice numbers. And on this side, 4, 5, and 6. Okay. And now we do the same process, right? So we have to plug all these numbers into our function and see what we get out. Okay. So, yeah, we can do this together. I was going to let you guys do it, but it's kind of hard for me to check what you guys could be doing, right? So let's see. So plug in -5. Okay, so let me see what we get. So I'm using a calculator. If you guys are wondering where I'm getting these numbers from, I hope these are right. what I got there. Right, so let's see. So -5 and positive 11.5, so way up here. -6 is 7. -7, 5.5-ish. So it looks like it's doing this. In the middle, -1 and -0.5. 0, 0, 1, 0. So it looks like it's kind of doing this. And on the other side, 4, 4.5, 5, 3.3, and then 6, 3. So it does cross it here. It may look like this ish when it comes to it. So this one crosses it there again. Okay. Any questions on this one at all?
Yeah, so the only reason why the middle curve is not, because you can never cross the vertex, right? So that's why it's just going back down.
Yeah, so I know it can go up, right? Because it cannot cross, so it has to go back down sometime. Yeah. And then remember, I'm using the bare minimum, right? You could do more. So you could plug in -4, all of these numbers, and you get more precise exactly where it's going, right? I'm just trying to help you guys out. You don't do too much. 3 numbers should be enough to see where the curvature is. And as long as you remember, it shouldn't cross certain points when it comes to it.
Say that point -1, -0.5 was actually -1, +2. It would curve upwards, right? It'd be okay because it could
so
cross.
So it would be like a
line.
little higher up. It would just go up here like that.
So it never opens up?
No.
Okay.
So let's say if you tried, what is that, 2?
Mm-hmm.
So if you try 2 in here, let's see what we get. So you get -1. So it'd be 2, -1. So yeah, it would go back down there.
Okay, I see.
Yeah.
I was just curious if it would ever curve up, but the actual equation, when you plug it into the function, would never equate to it curving upward. It would always curve it downward.
Exactly. So that's what I'm saying. Like, you could pick as many numbers to get more exactly how the graph would go, but 3 numbers should be enough to get you in between when it comes to it, because it's sometimes already going to give you a long list to begin with.
Thank you.
Mm-hmm. Any other questions? No? Okay. So let's finish the last example of this section. So like I said, it's not too difficult of a section, just kind of long because we have to do this chart. If it wasn't for this chart, it probably won't be as difficult to begin with. All right. So same situation. We have to factor this. So we get that. So we get our two vertical asymptotes at x equals 2 and x equals -2. So we're going to have the same situation as the top. We're going to have a long list to do. Okay. A horizontal asymptote. So we have the top bigger than the bottom. So we're either in 3 or 4. Okay. But if I add 1 to 2, because that's the degree of the bottom, that gives me 3. So that's not true. So therefore, we're in the best one, 4. We have none. Okay. So that's even better. So much less work when it comes to it. So we have literally none. Less work. Right, and now we just graph them and do our little cheat chart, and we're pretty much done for this question here. So we're going to graph our two verticals, no horizontal, so just two are verticals. So -2 and +2. And do the exact same thing we did above. So make a pretty lengthy t-chart, 3 to the left, so -3, -4, -5. The only three numbers in between, -1, 0, and 1. And then finally above, so 3, 4, and 5 down here. So if you notice, right, the most work is just doing this t-chart, right? Hopefully this isn't too difficult to find using our rules. And same thing, right? We just plug and chug and see what we get out. So again, I'll use the calculator to go a little quicker, see what we get. This is probably the same. Okay. All right, so this is way off the graph, so just I'll guesstimate. So like maybe something like this. That's weird. In the middle, -1, 0, 0.25, and then 1, 0. So it looks like it's going like this. And mirror to mirror the other side. I'm just going to do something like that. There you go, give or take.